Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you very much. So we're meeting again for part 3 of chapter 1, Introduction to Communication Systems. So we will go a little bit faster tonight, because of we need to get into around 10 minutes duration for one presentation. Okay, so this subchapter, this video will cover from 1.3 up to 1.6 from modulation and demodulation definition, transmission media, transmission modes, and also electromagnetic spectrum and transmission frequencies. Okay, so first we will discuss about the definition of modulation. What is modulation? Modulation is a process of impressing or applying a low frequency information signal. The keyword here is low frequency information signal onto a relatively high frequency carrier signal. So low frequency information signal, high frequency carrier signal. So that is the modulation process. This is the block diagram of the modulation process. This is the process. So here we have two input and one output. So what is the input and what is the output? The first input is low frequency information signal. Sometimes it also called a baseband signal. The second input is high frequency carrier signal. High frequency carrier signal, FC. Okay, this input come into the modulation process and will produce the output known as modulated signal. So that is brief description of modulation process. Okay, why we need to modulate? The need of modulation, why? So there are three main reason why we need to modulate the signal. First, noise reduction. Second, multiplexing. Third, frequency assignment. So what is noise rejection? The modulation process will reduce noise and interference. Okay, so multiplexing, the modulation process will help to transmitting two or more signals simultaneously over the same channel. So that is why the signal need to be modulated. And the third reason is frequency assignment. So we know that the TV and radio has different assigned carrier. For example, radio, we have so many radio station, so each station will have a different frequency, carrier frequency. So that's why the signal need to be modulated at different frequency, so that frequency can be assigned to each of those radio station. Okay, next, types of modulation. So what is modulation? There are a few types of modulations. In this subject, we will describe three main types of modulation. Namely, the first one is analog modulation, second is digital modulation, third is keying modulation. So analog modulation is the basic one, which cover AM, FM and PM. AM is amplitude modulation, FM is frequency modulation. PM is phase modulation. Okay, the next types of modulation is digital modulation. Here example is PCM, pulse code modulation. Okay, so this is digital, this is analog. And the third one is keying modulation. Keying modulation, which consists of ASK, FSK, and PSK. A is amplitude shift keying. F is frequency shift keying. P is phase shift keying. So basically there are three types of modulation: analog, digital, and keying modulations. Okay, next. The definition of demodulation. So after modulation process at the transmitter, we will have the demodulation process at the receiver. So what is demodulation? So demodulation is the reverse process of modulation. So what happens is it converting the modulated information sources back to its original information by removing the information from carrier signal. So we have the information, and remember the modulation process where we have two input, information and carrier. So at the demodulation process, we will remove the information from the carrier signal. So that is briefly the demodulation process. So remember, we have modulation and demodulation, the reverse of modulation. The transmission media. So we have described that transmission media is a medium that bridges the distance between source to destination. So in previous part we have described this media as a medium, any kind of medium that the signal transmit between the transmitter to the receiver. So this is example of a common transmission media. We will have fiber optics for digital signal. We'll have free space or air, or also known as atmosphere. Sometimes we say atmosphere, sometimes it is known as air, and it is basically the same thing. So free space, this is where the electromagnetic wave propagates, transmit. And another one is twisted pair. Twisted pair is the kind of wire that can be used to transmit signal at certain frequency. Okay, so you have three examples of transmission media: fiber optics, free space, and twisted pair. Okay, next. Now we discuss about the transmission modes. There are different between transmission media and modes. Okay, so modes can be transmission modes can be divided into three types. Okay, types. First, simplex. Second is half duplex. Third is full duplex. So what is this? There are one way, two way, or simultaneously. Okay, what is simplex? Simplex is one way transmission. You cannot communicate back to the device. Okay, example is radio and TV. Simple. So if you have radio or TV, you just receive the signal from the transmitter. This kind of transmission is called simplex. So you cannot you cannot communicate back, you cannot feedback to the transmitter. The second is half duplex. Half duplex is communication can be occur in both direction, but not at the same time. So the most common example for this kind of transmission mode, half duplex, is walkie-talkie. So normally when we discuss about half duplex transmission mode, the example is walkie-talkie. Do you know what is walkie-talkie? Walkie-talkie is the device used for communication, but only can talk at one person, talk at one time. Okay, so this is half duplex. The third transmission mode is full duplex. So full duplex is the common telephone. So communication can occur in both direction at same time. So both direction, anyone can talk simultaneously. You can talk at the same time from receiver and transmitter. So one can become transmitter when one can also become receiver at the same time. So this is known as full duplex. Okay, full duplex is both way at same time or simultaneously. Next. So the next topic is frequency spectrum. So what is frequency? What is spectrum? Frequency spectrum consists of all frequencies contained in the waveform and their respective amplitude in frequency domain. So frequency domain. So we have time domain and frequency domain. So frequency spectrum is all frequencies and their respective amplitude in frequency domain. Okay, we will see the example for this. So this is the example of frequency spectrum. We can see from here that we'll have wavelength and frequency here, sorry. So we have wavelength in the unit of meter, centimeter, meter, kilometer, okay. So these are the wavelength in the unit of meter. On the other side, we have frequency in the unit of hertz, which you already know. So you have here hertz, gigahertz, megahertz, kilohertz, hertz. Okay, so what is this? So wavelength frequency designation, we have ultraviolet, visible, infrared, and extra high frequency, super high frequency, and so on and so forth. On the other side, we have telephone, telegraph, AM broadcasting. Okay, so this is AM broadcasting where we are interested in this chapter, and we have FM, VHF TV, and FM frequency modulated. So you can see the range. AM broadcasting between 100 kHz up to 1 MHz. FM is around 50 MHz up to 100 MHz. Okay, the rest we can see later. So transmission media, different frequency or different wavelength will use different transmission media. So you can see a high frequency, you can use optical fiber, and low frequency we can use twisted pair cable. Okay, little bit high frequency we can use coaxial cable, and so on and so forth. Okay, next, frequency spectrum. Since this is quite same, but again we have here increasing frequency, increasing wavelength. So the smaller the frequency, the higher, the bigger the wavelength. Okay, here 100 kilometer wavelength, frequency only around 3 kilohertz. Here wavelength 1 millimeter, so the frequency is around 300 gigahertz. So it is reciprocal. The higher the wavelength, the smaller the frequency. So these are the application for this particular level of frequency range. Okay, so this is the relationship between frequency and wavelength. Frequency is simply number of times a particular phenomena occurs in a given period of time. So normally we will say how many rotation or how many rotation per minute or rotation per seconds. Okay, so but wavelength is the distance traveled by electromagnetic during one period. So the wavelength signal is represented by Greek letter lambda. So when we have this sine wave, we normally describe it as one cycle. So one cycle, one wavelength. Okay, so one wavelength is one cycle. Peak to peak is one wavelength. Okay, so how many cycle per second? That is frequency. Okay, so if we have sine wave, we can have wavelength and also frequency. So this is the relationship between frequency and wavelength. The equation is C equal to lambda f. C is speed of light, lambda is the wavelength, f is the frequency. That's all. That's all for this part. We will continue the last part later on. So that's all. Thank you very much. Assalamualaikum.